Okay, so hello and welcome back. So in this video we want to talk a little bit about exercise 14.3, and that is for each of the following compound statements. First, identify the connecting words and then break it into component statements. So you have these compound statements like all rational numbers are real and all real numbers are not complex. So number one is, for example, all rational numbers are real. All rational numbers are real. And all real numbers are not complex. And all real numbers are not complex. So here the connecting word or technically the connective is and, right? So that means that and has connected the two component statements. So the two component statements are basically all rational numbers are real. All rational numbers are real. And the other component statement is all real numbers are not complex. All real numbers are not complex. So here basically you're not supposed to judge whether basically specify whether the compound statement or the component statements are true or false. The only thing that you need to do is basically specify the connective, and then based on that write the component statements individually, which is what I have done over here. All rational numbers are real and all real numbers are not complex. So this is part one of this example. So part two is square of an integer is positive or negative. Square of an integer is positive or negative. So the connective is or. So you say the square of an integer is positive. The square of an integer is positive. And also you can say that the square of an integer is negative. And then the connecting word or the connective is or. So these are the two component statements. Part 3 of this question is the sand heats up quickly in the sun and does not cool down fast at night. The sand heats up quickly in the sun the sand heats up quickly in the sun and does not cool down fast at night. And does not cool down fast at night. So the connective is and the component statements are the sand heats up quickly in the sun. So number one, the sand heats up quickly in the sun. Quickly in the sun. And then you can say that the sand does not cool down fast at night. And the connective is basically and, which is what I have shown over here. The next part of this question is x is equal to 2 and x is equal to 3. X is equal to 2 and x is equal to 3 are the roots of the equation. Equation 3x squared minus x minus 10 is equal to 0. So then the connective is and here, and the component statements are x is equal to 2 is the root of the equation 3x squared minus x minus 10 is equal to 0, and x is equal to 3 is the root of the equation this equation. So that's basically that. That is basically that. Now the second part, the question number 2 here is identify the quantifier in the following statements and write the negation of the statement. So you want to identify the quantifier. So the quantifier of, for example, number 1 is there exists a number which is equal to its square. There exists a number which is equal to its square. And of course this is true because you know that 1 squared is equal to 1. So, and there is only one such number there is only one. There is, of course, there is more numbers. There is 0, there is -1, there is, I think there is only 3 numbers. But anyway, that's not the point. The point here is that you want to identify the quantifier, which in this case is there exists. That is your quantifier. That is your quantifier. And the negation of this the negation of this statement is that you can say that it is not the case. You can say it is not the case that there exists a number which is equal to its square. It is not the case that there exists a number which is equal to its square. And then you can rewrite this as I think you can say, for example, there exists no number which is equal to its square, or you can say, so basically what's written here is that there does not exist a number. This has been written as there they have simply written it this way. They have written it as there does not exist a number which is equal to its square. Which is equal to its square. Or the second part of this question is, for every real number x is less than x plus 1. X is less than x plus 1. For every real number x is less than x plus 1. So basically the quantifier here is for every, and you can say that, for example, the negation of this, you can say that it is not the case that for every real number x is less than x plus 1. And then you can write that as there exists a real number x. Oh, that's actually very smart. They have negated this as there exists a real number x such that there exists a real number x such that x is not less than x plus 1. That x is not less than x plus 1. So what this statement is saying, it says that it's saying that for every real number x, x is less than x plus 1, meaning that this applies to every real number x. And now if you want to negate this, if you basically show that basically even if there is one such number x such that x is not less than x plus 1, then that means that basically this statement is not true, or that you have negated this statement. So what that means is that then for the negation of for every, then you can simply use there exists a and so on and so forth. And so what we have said here now is that there exists a real number x such that x is not less than x plus 1. X is greater than x plus 1. And that negates this statement over here. That's actually a good way of negating this statement. Okay, so that is that. Okay, so the third part of this question says there exists a capital for every state in India. There exists a capital for every state in India. For every state in India. So the quantifier here is there exists. And of course, if you want to negate this statement, of course, there is for every here as well. But of course, for every is not a quantifier here. And if you want to negate this, well, of course, you would say probably you would probably say, for example, there does not exist a capital for. You could say there does not exist a capital for every state in India. That would be right. That would not be wrong, I suppose. Meaning that if you said, for example, there does not exist there does not exist a capital for every state in India. There does not exist a capital for every state in India. That means there is at least one state in India for which there is no capital. That could mean that. But now the way that they have negated this is that they have said that there exists a state in India. There exists a state in India. A state in India which does not have a capital. Which does not have a capital. So that's how they have negated this, which is of course absolutely right. And I suppose this is much better than what I had written. I suppose this would be better than what I had written. Now question number 4. Question number 4 is state whether the or used in the following statements is exclusive or inclusive and give reasons for your answer. So we have a couple of statements, there is or in them. You want to know whether these ors are exclusive or inclusive. For example, you say that the sun rises or moon sets. The sun rises and, or I'm sorry, not and, or the sun rises or moon sets. Well, I don't know much about the sun and the moon and how they behave, what they do. I don't really know much about that. But number 3, what was number 3? Oh, we forgot to do number 3. I mean, this is number 4, I'm sorry. So number 3, check whether the following pair of statements are negations of each other and give reasons for your answer. And the following pair of statements are negation of each other. So statement number 1, it says x plus y is equal to y plus x is true for every real number x and y. Is true for every real number x and y. So x plus y is equal to y plus x is true for every real number x and y. This is one statement. The other statement is there exists real numbers x and y. Statement number 2, there exists real numbers x and y for which x plus y for which x plus y is equal to y plus x, which is, of course, these are not negations of one another. Over here what we have said is that x plus y is equal to y plus x is true for every real number x and y. And here we have said that there exists real numbers x and y for which x plus y is equal to y plus x. This is basically, the two statements are not exactly the same thing, but they're not exactly the negations of one another either. So now if you want to write the negation of this statement 1, what you would write is that there exists at least basically one x and y for which x plus y is not equal to y plus x. So then you can write there exists real numbers x and y. There exists real numbers x and y. There exist real numbers x and y for which x plus y is not equal to y plus x. For which x plus y is not equal to y plus x. So this would be the negation of this statement over here, of course. But not this one. This one is kind of saying the same thing. So Now, question number 4. There is a statement over here that says sun rises. Sun rises or moon sets. So what this means is that, of course, you have two component statements. This is a compound statement using or. There is two component statements, sun rises and number 1 and number 2 moon sets. So if these two can be true simultaneously at the same time, then this or is going to be an exclusive or. Otherwise it's going to be, if both of these can be true at the same time, this or will be an inclusive or. Otherwise it will be an exclusive or. And based on the answer that I'm seeing here, they're saying that this or is an exclusive or. They're saying that this or is an exclusive or, which means that these two cannot happen together. Either this is true or this one is true, but but there is no time at which basically the sun is rising and the moon is setting at the same time simultaneously, both of them happening together. So this is an exclusive or. Or suppose that you say, for example, to apply for a driving license, to apply for a driver's license, you should have a ration card. You should have a ration card. Ration card is something in India, some sort of card that, for example, when you want to get gas, those gas tanks, cooking gas, for example, or some rations. Rations means the necessary things for life. Then you take your card and then you will be if you have the ration card, they will cost you much less, okay? So it says that to apply for a driving license, you should have a ration card or a passport. Of course, that's not true. Meaning the passport part is factually not true in India, most probably. Meaning most people don't even have passports. But maybe with the passport it's also possible. Anyway, so this is based on the answer that basically it seems that this or over here is an inclusive or. This is an inclusive or. So that when you say that this is an inclusive or, basically you have two component statements here. The first component statement is to apply for a driver's license, you should have a ration card. The second component statement is to apply for a driver's license, you should have a passport. So that means that if this is an inclusive or, which I'm saying this only based on the answer that I'm seeing here. If this is an inclusive or, then what that means is that you could, basically, if you had the ration card, you would get the driver's license. If you had the passport, you would get the driver's license. And if you had both of them, you would still get the get the driver's license. So now the next the next question that we have here is, all integers are positive or negative? All integers are positive or negative. All integers are positive or negative. So what that means is that and I don't understand this really. Let me see. Okay, so the answer over here is it says that basically this is an exclusive OR. This is an exclusive OR, and the reason why this is exclusive is that all integers cannot be both positive and negative. All integers cannot be both positive and negative. Of course, that's true. All integers cannot be both positive and negative. So this is an exclusive OR. So, of course, this is a tricky question. You don't know how to think about it, but that's true. Okay, anyway, that's basically this part. Now there is one more. There is one more part over here that's been called implications. And let's see what it is. Contrapositive and converse. Okay, so there is a couple more things here. Okay, so there is one more. The next part here has been called implications. I don't know what it is. We will go through it and see what we have. So I'll see you in the next video.